In this problem, we're going to calculate two surface gravities, one of the Earth, and then a comparison, we're going to calculate the surface gravity of the moon. In our previous question, we asked, is your weight on the moon more or less? And you should have got less because, as we'll see, the gravitational surface constant of the moon will be less. So we're going to start with our equation. The gravitational acceleration at the surface is little g, that is equal to capital G m over r squared. So g is Newton's gravitational constant, which is in the lecture slides, and that is 6.67 times 10 to the minus 11 meters cubed kilograms per second squared. So our units will do at the end, and we should get that the gravitational acceleration has units of acceleration. Then we have m, the mass of the attracting body, and r, the radius of the attracting body. So the mass will be in kilograms because in order to cancel our units with our gravitational constant, we have to have kilograms, and that means our radius will be in meters. And for everything that you'll be tested upon in this class, you'll be given things in kilograms and meters. So using our table, let's look at Earth. So Earth has a mass of 6.0 times 10 to the 24 kilograms and a radius of 6.4 times 10 to the 6 meters. So we're working with big numbers for the first time in this class, so we're going to go slowly through the scientific notation. So our gravitational acceleration is equal to g, which was 6.67 times 10 to the negative 11, times m, 6.0 times 10 to the 24, divided by r squared. So r is 6.4 times 10 to the 6, quantity squared. So this looks like, and this dot is a multiplication. It looks complicated, but it's actually very simple if you break it down into two steps. The first step, we're going to look at the prefixes of everything. So if we just do our prefixes, we have 6.67 times 6.0 divided by 6.4 squared. Don't forget, this guy applies to the prefixes. So if we plug that all into our calculator, 6.67 times 6 is 40.02, and then 6.4 squared is 6.4 times 6.4, that's 40.96. So if we do that division, 40.02 divided by 40.96, we get, rounding to two places after the decimal, 0.98. So that is our blue prefix we'll use as our answer. So then we have to go back and we have to look at our exponents. So we have a negative 11, a 24 in our numerator, and then a 6 squared in our denominator. So when you multiply things with exponents, you add the exponents. So everything in a red box is going to be added, except when you multiply something by squaring it or cubing it, for example. So in our numerator, we have our exponents of minus 11 and positive 24. So our numerator has those two exponents. When you have a 6 squared, it's like multiplying them together. So 6 times 2 is 12. So 24 minus 11 is 24 minus 11, 13 over 12. So when you have a division of exponents, it's the opposite of having a multiplication of exponents. So when we multiplied our exponents, we added the exponents together, and now we have a division of things with exponents, we subtract them. So 13 minus 12 just leads us to our exponent of 1. So what we do now is we multiply by 10 to whatever our exponent is at the end, which was 1. 10 to the 1. And putting these two things together, that is our final answer. If we want to put it in perfect scientific notation, which is not required, it's 9.8 times 10 to the 0. Then for our units, if we multiply a G, so G's units are meters cubed, kilograms, seconds squared. You multiply it by a mass, which is in kilograms. And you divide it by this squared. Sorry, I have the units of G incorrect. This kilograms in the units of G are in the denominator. So now the units of G, the kilograms will cancel. Meters cubed divided by meters squared just becomes meters. So what's left is meters in the numerator and seconds squared in the denominator. This is true for every time. You can just use this in your answer. So that is our units. So if we come down here to our final answer, our units are meters per second squared. So the surface gravity of Earth is 9.8 times 10 to the 0 meters per second squared. So let's do an overview of what happened. The equation we use for surface gravity is given in the lecture notes. It was discovered by Isaac Newton. It is the Newton's gravitational constant times the mass divided by the radius squared. Since it's an acceleration, we get its units to be meters per second squared. In our table, we were given the mass and the radius of Earth, which was 6.0 times 10 to the 24, and the radius of 6.4 times 10 to the 6. We plugged them into our equation. We did our prefix multiplication of the 6.67, the 6, and the 6.4 squared, and found that our prefix was 0.98. Then we did the hardest part, which was looking at the exponents, 10 to the negative 11, 10 to the 24, and 10 to the 6 squared. And that gave us a final exponent of our multiplication and division of 1. So that gave us our final answer of 0.98 times 10 to the 1, or 9.8 meters per second squared. So let's repeat this process with the moon. So the moon, let's not use red. If we go back to the lecture slides, the moon has a mass of 7.3 times 10 to the 22 kilograms and a radius of 1.7 times 10 to the 6 meters. So the gravitational acceleration is 6.67 times 10 to the negative 11 times the mass, 7.3 times 10 to the 22, divided by the radius squared, 1.7 times 10 to the 6, quantity squared. So we're going to do the exact same procedure. We have our 6.67, our 7.3, and our 1.7 squared. So our prefix, 1.67 times 7.3, divided by 1.7 squared. Our numerator is 6.67 times 7.3. So that is 48.691. And then we divide that by 1.7 squared. which is 2.89. So if we divide 48.691 divided by 2.89, we get 16.84 as our prefix. So now we need to look at our exponents. We have negative 11, 22, and 6 squared. So in our numerator, we have negative 11, positive 22. In our denominator, we have 6 squared. When you square something, you multiply the exponent. So that's 6 times 2, which is 12. We get 22 minus 11, that's 11, divided by 12. And when you divide exponents, you subtract. So this is negative 1. So our exponent we use is negative 1 times 10 to the negative 1. This comes from the red. Our units are the same, meters per second squared. So if we write this in perfect scientific notation, 1.684 times 10 to the 0 meters per second squared. So comparing Earth, 9.8 is much higher than 1.68. So the surface gravity of Earth is much larger than that of the moon.